In problems 4 and 5, we're going to use a different simulation. On my teaching page under MBA 620, you're going to download and open Aggregate Market Model 3 to do the problem in 4 and 5. Now the reason why we're using a different simulation is because there's much fewer inputs. The MPC equals 0.75 here, the MPM equals 0.25. Potential GDP is given as 15.25. Short aggregate supply has an intercept of 2.74, a slope of 1. Aggregate demand has an intercept of 22.78. As you can tell, all of the values from the problem have been inserted into this Excel spreadsheet. Now, we want to compute the equilibrium level of real GDP, and it is equal to 13.36 because that is the intersection of aggregate demand and short-run aggregate supply, 13.360. The price level is 16.1. So I'm going to type in 16.100 here. The output gap is the difference between what real GDP is and potential. So this is what real GDP is, and this is what it should be if the economy is if the resources in the economy are fully employed. So I'm going to copy this into Excel to compute the output gap. So the output gap is a negative 1.890. And this diagram looks just like the one that's in Excel. We have PL over here, a price level, which is in $1,000. We have Y, or real GDP, down here because it's in trillions, and it's in trillions of dollars. This is short-run aggregate supply, aggregate demand, long-run aggregate supply. Aggregate demand and short aggregate supply intersect to the left of long-run aggregate supply, so GDP is less than potential. So the economy is in a recessionary gap. Now suppose economists at the CEA estimate that a $2.835 trillion, it has to be an increase in government expenditure because we need to stimulate aggregate demand. We'll close the output gap. So economists at the CEA estimate that a $2.835 trillion increase in government expenditure will stimulate aggregate demand such that it will pass through that point. If the CEA's recommendation is adopted by the Congress and the President, show how it affects aggregate demand. All we have to do here is take the initial aggregate demand intercept of 22.78, using the hint here. We take the initial aggregate demand intercept and add to that the value of the increase in government expenditure. I'm going to calculate that in Excel. So we have the initial intercept plus the increase in government expenditure, and we get 25.6. The slope of aggregate demand has not changed, so it is still 0.50. To double check that the intercept, the new intercept, is correct, we can take the value of the increase in government expenditure. We can copy that and paste it into our spreadsheet here. And we should get the same intercept, 25.615. So we just double checked that we did that work correctly. Now we're going to use the diagram that Excel produces to get the new equilibrium. So notice that the increase in government expenditure shifts aggregate demand to the point where short-run aggregate supply and long-run aggregate supply all intersect. So the equilibrium level of GDP is equal to potential GDP. So we copy the potential GDP level into the equilibrium level of GDP here. According to the diagram, the price level is 17.99. The output gap is 0. Now to get the multiplier, we have to take the ratio of the change in GDP over the government spending multiplier. So what was GDP? GDP was 13.360. What is GDP now? It's 15.250. So the government spending multiplier is equal to the increase in GDP, this difference, divided by the increase in government expenditure, which is 2.835. So again, the multiplier is the increase in GDP, that difference, divided by the increase in government expenditure. So I'm going to copy this into Excel to compute the multiplier. So the increase in GDP is that value, and the increase in government expenditure is that value. So the multiplier is equal to 0.667. This diagram shows the exact same thing that's going on here, except it gives you the initial and the final aggregate demand curve. So the initial aggregate demand curve is here. After the increase in government expenditure, we have a new aggregate demand curve here. So we have this increase in GDP caused by the increase in government expenditure. In part D, we want to calculate the growth rate, inflation rate for the scenario we just completed. First, I copy the initial equilibrium into Excel, $13.360 trillion and $16.10 thousand dollars. So this is the initial equilibrium. Then I copy the final equilibrium, 15.250 and 17.990 into Excel. So this is the final equilibrium, and this is the initial equilibrium. To calculate the economic growth rate, you take what GDP is, 15.25, subtract off what it was, and then divide by what it was, and then you multiply this by 100 to convert it to a percent. So the economic growth rate is 14.14671%. The inflation rate is computed the same way. What the price level was, what the price level is minus what it was, divided by what the price level was times 100. So the economic growth rate is 14.14671. We're going to copy that into scenario A of part D. We're going to copy the inflation rate into this answer blank here. And we want 3 decimal places, so because the fourth is a 1, we can delete that. Because the fourth decimal place is a 7, the 6 becomes 7. And then we got to answer this question here. Which curve is the steepest in scenario A? In scenario A, it looks like the short and aggregate supply curve is the steepest. So it's relatively more inelastic. So short and aggregate supply is relatively more inelastic than aggregate demand because it's steeper. Now we're going to go do scenario B. All of the initial conditions in scenario B are identical to those in A, except the short and aggregate supply has a different initial intercept and a different slope. Potential output is still 15.25. The aggregate demand intercept is still 22.78. The slope is still 0.500 because the MPC hasn't changed and the MPM hasn't changed. And these values have all been copied into the spreadsheet we use for scenario A. The initial equilibrium in scenario B has the same GDP level that was the case in scenario A initially, 13.360. The equilibrium price level has changed though, because short aggregate supply is now flatter than it was in scenario A. So the initial equilibrium price level is 16.1. Because GDP is the same as it was initially in scenario A, and potential GDP is the same as it was in scenario A, the output gap is still negative 1.890. If you copy this into Word, you have to label it. This right here is the short and aggregate supply curve. This is the aggregate demand curve. This is the long run aggregate supply. This is price level, or PL, in thousands of dollars. This is Y, or real GDP, in trillions of dollars. The economy above is in a recessionary gap. Economists at the Council of Economic Advisors estimate that a $1.4175 trillion increase in government expenditure will close the gap. So we have to recalculate the intercept. According to the hint, you take the original intercept of aggregate demand, 22.78, and you add to it what the increase in government spending has to be to close the gap. So I'm going to calculate that in Excel. So the original intercept is 22.78. The increase in government expenditure is 1.4175. This new intercept is 24.2. To double check that we did that correct, we can take this increase in government expenditure, copy it, and paste it up here in Excel. And when we hit enter, the aggregate demand curve down here will shift to the point that corresponds to the intersection of long run aggregate supply and short run aggregate supply. And the new intercept is indeed 24.198. To 3 decimal places, correct? The slope is 0.500 still, because the MPC and the MPM still haven't changed. The new equilibrium level of real GDP is the intersection of aggregate demand and short aggregate supply, which is at potential GDP $15.25 trillion. The price level at that same point is 16.573. Because real GDP equals potential GDP after the increase in government expenditure, the output gap is 0. To find the multiplier, we take the increase in GDP, so what GDP is currently, minus what it was. So we take the increase in GDP here and divide it by the increase in government expenditure. We're going to calculate that in Excel. So this is the increase in GDP. We divide that by the increase in government expenditure to get the government expenditure multiplier, which is 1.333. This is the same diagram that we produced down here, but this diagram shows what aggregate demand was before and after the increase in government expenditure. So this is initial aggregate demand, final aggregate demand, long run aggregate supply, short run aggregate supply, PL, or price level, in $1,000, real GDP, or Y, in trillions of dollars. In Part D, we want to calculate the growth rate and the inflation rate for scenario B. In scenario B, Initial real GDP was $13.360 trillion. The price level is $16.1 thousand. We've copied those values right here. After the increase in government expenditure, real GDP increased to $15.25 trillion, and the price level rose to $16.573 thousand. Now, in Cengage now, we rounded to 3 decimal places. I don't have it rounded to 3 decimal places here. I got this value from our aggregate demand, aggregate supply graph that we did in Excel. What I did is I clicked on this label and then just copied the number and pasted it here to have better accuracy. Now, the economic growth rate is the percent change in real GDP. So H2 is what GDP is, D2 is what it was, and we divide that difference by what it was and multiply by 100. The inflation rate is the same calculation, but we're using price levels. H3 is what the price level is, D3 is what it was. So the inflation rate now is only 2.934783. We'll limit that to 3 decimal places. We'll copy this inflation rate from scenario B into part D of the Cengage Not a Problem. The economic growth rate hasn't changed. Like in scenario A, it is 14.147%. If you look at the diagram in scenario B and you compare short and aggregate supply to aggregate demand, you can easily tell that short and aggregate supply is flatter or relatively more elastic than aggregate demand. So short and aggregate supply is relatively more elastic than aggregate demand. In scenario C, potential output, aggregate demand are identical to what they were in scenarios A and B. The only thing that has changed here is short and aggregate supply has an intercept equal to 16.1 and a slope equal to 0. The slope of aggregate demand is still 0.500 because the MPC and the MPM are still 0.75 and 0.25 respectively. To compute the equilibrium level of real GDP, equilibrium price level, and the output gap, we're going to use the graph after we inserted these numbers into our Excel simulation, which I've already done. So I have intercept for the short and aggregate supply equal to 16.1, slope equal to 0, aggregate demand hasn't changed, and potential output hasn't changed. Down here in the diagram, you see long run aggregate supply, short run aggregate supply, and aggregate demand. Aggregate demand and short run aggregate supply intersect at the point that corresponds to a GDP level of 13.36. I pasted 13.360 into Cengage now. Because the short and aggregate supply curve is perfectly elastic, the equilibrium price level is equal to the intercept of short and aggregate supply, which is 16.1. The output gap is equal to what GDP is, in this case 13.36, minus what it should be, 15.25. I'm going to copy and paste this difference into Excel to compute the output gap. 13.36 is what real GDP equals. 15.25 is what it should be equal to, potential GDP. So the output gap is negative 1.890. Here's the diagram that you see in Excel. This is short run aggregate supply. It's perfectly elastic. This is long run aggregate supply. This is aggregate demand. The equilibrium is to the left of long run aggregate supply. So we're in a recessionary gap. Up here we have the price level, or PL, in thousands of dollars. Here we have real GDP, or Y, in trillions of dollars. Now the economists at the CEA estimate that a $0.945 trillion increase in government expenditure will close this gap. In order to get the final aggregate demand intercept, we add the value of the increase in government expenditure to the initial intercept of the aggregate demand model, 22.78. I'll copy this into Excel to compute it, 23.725. To double check that this is the correct answer, we can simply substitute this into the change in government expenditure in the simulation. So once I hit enter, we're going to see the aggregate demand curve shift from the recessionary gap to this point here. And of course, the final aggregate demand intercept is 23.725, which is what we have here. The slope is still 0.500 because the MPC and the MPM are still equal to 0.75 and 0.25 respectively. To compute the final equilibrium level of real GDP, equilibrium price level, the output gap, we're going to use the diagram in Excel. Where aggregate demand and aggregate supply, short and aggregate supply meet, real GDP is equal to 15.25, the level of potential GDP. So the output gap is 0. The equilibrium price level, because short and aggregate supply is perfectly inelastic, the equilibrium price level is equal to short and aggregate supply's intercept, 16.1. The multiplier is the increase in GDP, which equals what GDP currently is minus what it was initially, 13.36. So that is the increase in GDP, and we've got to divide that by the size of the increase in government spending, which is 0.945. So we have the increase in government expenditure divided into the change in GDP. So the multiplier is, again, equal to the increase in GDP over the increase in government expenditure. It is equal to 2 in this case. This diagram shows you exactly what went on in Excel, but it gives you what aggregate demand was before the increase in government expenditure, what it is after the increase in government expenditure. So this is initial aggregate demand, final aggregate demand, long run aggregate supply, short run aggregate supply. This axis is labeled the price level, or PL, in thousands of dollars. This is labeled real GDP, or Y, which is in trillions of dollars. In part D, we have to compute the growth rate and the inflation rate for scenario C. In scenario C, the initial level of GDP was $13.360 trillion. The initial price level was $16.100 thousand. And I pasted them right here. After the stimulus was passed and enacted by Congress and the President, real GDP increased to $15.250 trillion. The price level was constant because the aggregate supply curve is perfectly inelastic. Those final values were pasted in Excel here. The economic growth rate is percent change in GDP. It is $15.25 trillion. It was $13.36 trillion. The inflation rate is the percent change in the price level. Because the price level did not change, the inflation rate is 0. The scenario C, inflation rate is 0%. The economic growth rate is always 14.147%. The short and aggregate supply curve is perfectly elastic in scenario C. So, what was the whole point of this problem? Well, the government spending multiplier starts out at 0.667 when short and aggregate supply is relatively inelastic. As the slope of short and aggregate supply falls, or as short and aggregate supply becomes relatively more elastic, the value of the multiplier increases in value. In scenario B, the multiplier was 1.33 when the short aggregate supply curve was relatively more elastic than aggregate demand. The government spending multiplier reaches its maximum value of 2.0 in scenario C because the short aggregate supply curve is perfectly elastic. As the value of the multiplier increases from scenario A to B to C, the inflation rate declines from 11.739 to 2.935 to 0.000. The inflation rate is the highest in scenario A because short aggregate supply is relatively inelastic. In other words, because the short aggregate supply curve is steepest in scenario A, the inflation rate is the highest. In scenario C, the inflation rate is 0.0% because short aggregate supply has zero slope. Thus, the government expenditure multiplier increased in value as the slope of short aggregate supply declined towards zero. The inflation rate that resulted from the increase in government expenditure is higher when short aggregate supply is relatively more inelastic than aggregate demand. The government expenditure multiplier in scenario C equals the government expenditure multiplier in the AE model because the price level is being held constant as the increase in government spending is analyzed. Now we're going to check out my work, and I should get all the questions correct. And it looks like everything is correct.